Hi guys, what's up again? So today in this bright winter morning I think last time we did something related to gaseous mixtures, right? So where I started telling you something related to Gay-Lussac's law, then we completed Avogadro's law, right? Then I told you certain assumptions that you should remember, like that you should keep in mind when we start studying anything about the gaseous mixtures. Fine. But I remember I ended up my discussion saying that there is something more in the gaseous thing that you need to understand. Because this topic, the topic that I have chosen, so in this topic mole concept, you will literally be getting so many questions which will be from the topic gaseous state as well. Okay, so that means although this gaseous state chapter is I think chapter number 5 in NCERT class 11th. But this is so important that this chapter we will be studying along with this chapter. Like whatever is the common part for mole concept and gaseous state, I will be discussing in this video of mine. Fine. Now before I continue with anything, I'll just tell you how to write the balanced chemical equations and how to work with the equations which are concerned about gaseous substances. Okay, so let us start one by one and let us continue with the balancing of gaseous reactions. So coming on to the very first thing of today, that we need to write the equations for organic gaseous reactions. Like for example, if I'll tell you, let's say there is one particular reaction C plus O2. So you can very easily say that ma'am, it will lead to the formation of CO2, right? Instead, if I write CH4 plus O2, then also you can say, ma'am, we'll be getting CO2 plus water, alright? Suppose instead of CH4, I have any particular hydrocarbon. What is hydrocarbon? Guys, this hydrocarbon is nothing but a compound which is made up of hydrogen and carbon. They may be present in any particular ratio. Okay? As per in class 10th, you would have studied the hydrocarbons could be an alkane or it could be an alkene or it could be an alkyne. May it be any hydrocarbon. Now I'll tell you how to write a balanced chemical equation for the reaction of hydrocarbon with oxygen. Okay. So let me just write it down. Let us consider a hydrocarbon where X atoms of carbon and Y atoms of hydrogen are there. So when you treat it with oxygen, it will lead to the formation. Since it's a hydrocarbon, so you just need to remember it will lead to the formation of CO2 and water. Okay. Now you don't have to mug up what we'll be getting. You just have to understand the basic concept how this reaction is to be written. Okay. So now my main aim is to balance this particular equation. Now how should I be balancing this equation? So listen to me very carefully. This equation has carbon, hydrogen and oxygen. First of all, you need to leave hydrogen and oxygen aside and balance all the other atoms other than hydrogen and oxygen. So now here the other atom other than hydrogen and oxygen is just carbon. So you need to start balancing carbon. Let's see how it is to be balanced. Write the equation again. Equation is CXHY plus O2 to form CO2, and let's say water is also there. See how many carbons are there on the left hand side? There are X carbon atoms. So how many carbons are there on the right hand side? Just one. So you need to multiply it with X. Okay, so that's the first step where you need to balance the number of carbon atoms, X carbon here and X carbon there. After the balancing of carbon atoms, what you need to do is to start balancing either hydrogen or oxygen. Okay. Now the question is, ma'am, which one of hydrogen or oxygen should be balanced first? Now listen again. Out of hydrogen and oxygen, you need to choose that particular molecule or that particular atom which is present independent. See, what do we mean by independent? And that's well obvious, right? See, here if you bring about any change in the number of hydrogen, there will be an equal change in the number of carbon, right? That means here this complete compound is altogether one compound. So whenever you are thinking of bringing any change in hydrogen, there will be an equal change in carbon. But I have already fixed carbon. Here carbon is just 1 CX. That means only X carbon atoms are there. If I put any number, let's say Y, Z, anything if I put here, then there will be equal change in carbon also, which I don't want. Okay. However, if I write anything here in above oxygen, so in front of oxygen if I am writing anything, may it be S, P, O, Q, anything if I am writing, it may be any number. That means there won't be any change in carbon and hydrogen, right? So now out of hydrogen and oxygen, you just have to leave away the atom which is independent. So just leave it aside and then move on to the balancing of hydrogen. Okay. So let us see what is the final equation that we will be getting. So that's the equation that I have. Here carbon is X and I have fixed it. I will enclose it in this dabba. I will enclose it in this box. I will not change the box. How many carbons are there? X carbons. So I have written X. Now I have enclosed this as well. I can't bring about any change in these two molecules. Okay. Now see, if I have enclosed this complete compound in a dabba, how many hydrogens are there? So you will say, ma'am, there are Y hydrogens, right? Now we need to make a total of Y hydrogens on our right hand side as well. How many hydrogens are there? 2. But how many I need? Only Y. So don't you think I can multiply it with Y by 2? Why so? Because see, Y by 2 into 2 is nothing but Y, right? So with these two things, I have already balanced the number of carbon and hydrogen. Now what I am left with is to balance the oxygen atoms. Let's see how many oxygens. Guys, see, this is fixed. I can't bring about any change. This is fixed. I can't bring about any change. Can you tell me what is the number of total oxygen atoms on the right hand side? Total oxygen atoms on the right hand side will be 2x plus Y by 2. Take a minute and see if this is okay. Total number of oxygens on right hand side is 2 times x plus Y by 2. So what is my aim now? So now my aim is to make the total number of oxygens on the left hand side also as 2x plus Y by 2. But already here we have 2 oxygen atoms, like 2 are there. So what should be the number that I should multiply it with? So here I am writing star. Now what should be the value of star? Let's see. Guys, see, if I will be writing instead of star x plus Y by 4 O2. Now let us calculate the total number of oxygen atoms. So you can say, ma'am, 2 multiplied by x is 2x plus Y by 4 multiplied by 2. Okay, which will come out to be 2x plus y by 2. Fine. So guys, this is how we have balanced a chemical reaction which contain CXHY as our hydrocarbon. So this was the hydrocarbon that was available to us. How we had to balance it, this is the procedure. Okay, so this was just one particular chemical reaction, but there are other two chemical reactions also which are very common and many a times they are asked in exams. So I will ask you to quickly note down all these things so that I can get space to tell you something else also. Note it down quickly. Guys, I think you are now done writing down each and everything which was written on the board. Having done this, what I think now is I'll tell you something, another important reaction. Okay. Let's say now the reaction that I'm going to choose is having both carbon, hydrogen and oxygen. So earlier what we did, there were only carbon and hydrogen. Suppose there is any particular organic compound which is given which contains carbon, hydrogen and oxygen, and now it is ignited with oxygen. What is the meaning of ignited with oxygen? Ignited means simple reaction with oxygen. So what will be the balanced chemical equation? Let's see. We have compound could be anything. I have just written carbon containing, like there are X atoms of carbon, Y atoms of hydrogen and Z atoms of oxygen. I am reacting it with oxygen. I don't know anything, but it will lead to the production of CO2 and water. Okay. And now I need to do something in order to balance. I will again follow the procedure. What will be the steps in the procedure? First of all, balance the number of carbon atoms. Am I right? After the balancing of carbon atoms, I'll say balance the dependent atom. Like whatsoever be the dependent atom, you need to balance. In this particular case, carbon if you will balance, oxygen is independent. So you need to balance the hydrogen atom. Am I right? And finally what you need to do? Balance oxygen atom. Okay. So these are the three things which we need to follow in order to get a balanced chemical equation for this reaction. Let me start writing down the equation in order to balance carbon. So CXHYOZ plus O2 leading to the formation of CO2 plus water. What should I do? Here number of carbon atoms, fix it, enclose it in a dabba, in a box. You need to remember that enclosing is important so that you can't change the thing again. How many carbon atoms you have done on the left hand side? X. So what should I do? X. Enclose it in dabba again. Alright? So okay, once this is done, let's move on to the second step. Second step is to form XCO2 plus water. Now first of all, what all are to be enclosed in a box? Fixed. How many hydrogen atoms are there on the right hand side? So there are total Y atoms of hydrogen on left hand side, Y atoms. So you need to make this also as Y. What should I do? See, don't do Y only, because Y into 2 will be 2Y. So you need to multiply it with Y by 2, because now Y by 2 into 2 will be Y. Fixed, enclose it in a dabba. Done. Now finally what is to be done? Balancing of oxygen. How many oxygens are there on the right hand side? Calculate very properly. 2 times X plus How many oxygens? Y by 2. I think there are no doubts as of now, right? Okay. Moving ahead. Now don't just think about this particular oxygen atom. Don't forget that there are Z oxygen atoms already available on the left hand side. Okay. So when Z are already available, how much more do I need? This is what I need to find out. So let's see. So this will be CXHYOZ and this I am fixing. So Z oxygens are already available. Plus I need to multiply it with something in box times O2. Okay. And then I need to write X CO2. This is already enclosed in a box and Y by 2 water. Right? So what should be there in the box? Now right hand side, oxygens are 2x plus Y by 2. So right hand side oxygens are 2x plus Y by 2. Left hand side oxygen atoms are Z. How many more do we need? Don't you think I need to subtract the left hand side from the right hand side? So oxygens needed. How many oxygens are needed? See if it is clear or not. I need a total of 2x plus Y by 2 minus Z oxygens. And how many are available? See, we have something like this, if you remember. Right? So this was there. Now I need to fill something in this box. What is that something? This we need to figure out. That means already a multiple of 2 of oxygen is available. So can I say, here instead of writing 2x, I can just write x, right? Here instead of writing y by 2, what should I be writing? I need to write half of it, y by 4. Here instead of writing just z, what do I need to write? Z by 2, okay? Now if I ask you to simply write down the balanced chemical equation, I'll not be going here because I'll have to repeat it. Let me just come back and write down the equation here. See, now the final answer will be x plus y by 4 minus z by 2. Guys, let's do one thing. Let's quickly check out whether this equation is a balanced chemical equation or not. Okay? Start one by one. Choose carbon. X. Happy? Hydrogen how many? Y. Y by 2 into 2, which is again Y. Am I right? Oxygens how many? Oxygens will be C. Z plus x into 2 plus y by 4 into 2 minus z by 2 into z. Is it clear? Now how many? Okay, so let me write it again for you guys. Since this is done, I can remove out. Let's see, count the number of oxygen atoms again, because this was the important task. Oxygen atoms total will be Z plus 2 into x, 2x, plus y by 4 into 2, y by 2, minus z by 2 into 2, z. Z got cancelled, 2x plus y by 2, right? Let us see how many oxygens are there on the right hand side. X into 2, 2x, plus y by 2. Oh wow! So we got the same number of oxygens as well, right? See, I followed exactly the same procedure. But following the same procedure, I will not ask you to mug up this bad equation. This is so bad that even I can't remember, and I won't ask you people to remember, okay? But if you know the procedure,